Yeah, so let's wait for people to get in, like a few minutes to just to wait for our guests to enter the room.
Okay.
Okay, I see people entering. Okay. We may wait just a couple of minutes for those who are connecting now to give the time to those who are a bit late to join the room. Okay, I think we reached 50% of the registered people in the room, so I think we can start. Good afternoon, everyone. Good morning, everyone. And my name is Davide Sabadin. I'm working at European Environmental Bureau. Welcome to this webinar that we host in our corporate campaign. This is the first of a series of webinars that we are organizing in the framework of this campaign that we have ongoing. Just focus on the best practices from both sides of the Atlantic, and how to decarbonize buildings, and more precisely, and we're looking at ways to decarbonize heating and cooling, which is the most important energy consumption in buildings. Yesterday in Brussels, we witnessed an unprecedented change of pace in the policies and decarbonization of buildings and our economy in general, with the REPowerEU package covering the main aspects of both production and consumption of energy. Among other things, like there was the increase of our targets for renewable energies in the mix, and it's going to be 45% by 2030. Again, also the increased target for energy efficiency from 9% to 13% by 2030. And remarkably, we have now a ban on sales date for gas boilers, gas-only boilers, which is 2029. Which is something we've been advocating for a long time, and it's now there on paper. And it's way too late because Germany and Netherlands are looking at 2026. But it's still remarkable that we have a very clear indication for the market. At the same time, we have this objective 10 million heat pumps to deploy, a strong emphasis on district heating, and more policy steps that are making more credible our commitment to decarbonize the heating sector in Europe. So, so it's a bit sad that it was the new geopolitical situation that prompted the European Union to speed up the pace of change and not the climate emergency. And indeed, we have to say that still, even with this move, we're not in line with the Paris Agreement objective. But still, it's a welcome change of pace. And when we had in mind this webinar, we just saw that. Because the decarbonizing building should be the first and foremost action to take, because it's somehow the low-hanging fruit compared to aviation or heavy industry, for instance. We thought of focusing this awareness-raising webinar series on how to abate parts of the building stock, typically households where you have low income, so low. Therefore, you don't have access to investment to change the heating system or the envelope, or densely populated areas, tall buildings and hard to abate buildings, and of course, heritage buildings. And so we started from one building that has it all. Takes almost all the boxes. Probably not the ones of low income households, but surely is a very tall building. It's also blocks of flats, so a condominium. It's hard to decarbonize because it's quite old, and it's definitely a heritage building. So it's one that seems to be an impossible mission, so to say. It's the world famous Empire State Building in New York City. And so to properly quote a famous song, if I can make it there, I'll make it anywhere. So let me introduce you to Brett Bridgeland, which is our guest today, who's speaking from US, Colorado, if I'm not mistaken. He's a manager for Decarbonized Building at program at MI, formerly known as Rocky Mountain Institute, and he's been following the project of decarbonize the Empire State Building quite closely for a while now. Thanks a lot, Brett, for being with us. You'll lead us through the technological and policy aspects of the decarbonization of such a famous building. And after your presentation, for the sake of those who are connected, we'll have a question and answer session. I've got plenty of time for both technical and less technical questions. So we'll open the floor for these questions. You have a question and answer chat. Please refrain from writing or asking questions in the other chat. If such an option is there for those who are not panelists. But you have a question and answer, we'll pick up the chat and the questions and ask them to Brett on your behalf. And as I can guarantee, there will be plenty of time. The idea here, of course, and with this I close, is that we talk about like difficult situations to see if we can really tackle the problem there. I think we can learn lessons on how to tackle the problem pretty much anywhere in densely populated areas in Europe and elsewhere. And with that said, I leave the floor to Brett. You're muted, Brett.
Okay, there we go. Are you seeing my presentation and can you hear me?
Yes, we can.
Great. Okay, so thank you, David, for that introduction, and I'm excited to be talking to this group today. I think we're really excited about opportunities to share technologies and solutions across the Atlantic, like you said. And so today I'm going to dig into a challenging building typology, or kind of a range of typologies, as illustrated on this screen skyline of Manhattan, and starting with this case study of the Empire State Building pictured there in the sort of in the background of this picture. And what I'm going to do is walk through a little bit of history, a bunch of present, a bunch of activity that's exciting, it's going on in New York, and then a little bit about the future and how we could keep this dialogue open across the Atlantic. And so I'm going to start the conversation here about 10 years ago. And so my organization, RMI, known at the time as Rocky Mountain Institute, now we're officially just RMI, engaged with the Empire State Building in what we now affectionately call Empire State Building 1.0, which was this deep retrofit about 10 years ago, working with the ownership of the Empire State Building and a number of other stakeholders to look at what they could do to make a drastic cut in energy consumption. And energy was the word at that point. And what was really exciting about this project, it was a sort of a capital planning and an energy modeling and planning exercise. And it made a series of investments in the buildings in one comprehensive deep retrofit project. And it started, as we like to say, from the outside in. And so this building at the time actually retrofitted over 6,500 windows. By taking these windows down overnight, there's a window manufacturing plant that was built on one of the lower floors of the building, adding an additional pane of glass and coating, and then reinstalling the windows. They did this with 6,500 windows to drive down the cooling and heating loads. And then there were a number of other energy reduction measures throughout various end uses in the building. And so with all those investments, where it became really exciting is that because of those investments, the building was able to avoid a chiller plant retrofit that would have cost about $17 million. And so that immediately, that offset of capital, would be capital cost, drastically shortened the payback period of this building, and this project was able to achieve a simple payback within 3 years, which is pretty incredible. And so 10 years later, the principles of this deep retrofit project are still evident, taking a holistic look in making efficiency investments that can actually even save on the capital cost and unlock deep savings. And so through this project, the Empire State Building was able to reduce energy consumption by over 30%, which is pretty impressive. Fast forwarding 10 years to where we are in New York today, there's a couple pieces of context which are important. The policy landscape, which I'll just touch on here briefly, has really accelerated in New York, and there are two things to highlight. One is at the state level. So New York State has adopted aggressive targets for decarbonizing its economy. And so carbon-free electricity, the target is 70% by the year 2030 and 100% by 2040. And then economy-wide, 40% by 2030, and then achieving total decarbonization by the year 2050. And so there's big policy push at the state level. And then at the city level in New York City, there's a building performance standard called Local Law 97, which is setting carbon caps on large buildings, buildings over 25,000 square feet, excuse the imperial units. So that's over 50,000 properties in New York City that by 2050 will achieve an 80% carbon reduction. And keep in mind that the electricity supply is decarbonizing at the same time. And it comes in phases. So in 2024, the first standard will hit, and something like 20% of properties will need to do carbon abatement. And then in the following phase, by 2030, around 3/4 of buildings will have to make adjustments. And so this is creating an ecosystem of action around carbon abatement in larger commercial buildings. And then I would just note, today I'm talking about existing buildings, but on the new construction side, now we're talking about there's a gas ban coming that'll be phased in over the coming years for new construction as well. So all of this contributes towards building an ecosystem of decarbonization. If you're interested in policy aspects, tune in on June 14th, I believe. There's going to be a second webinar from one of my friends in the New York ecosystem who's more familiar with the policy and can dig into the nuances. So with all of that, New York State's energy office, known as NYSERDA, was tasked with figuring out what we could do to support this transition to decarbonizing buildings. And I'm going to talk some here about this program called Empire Building Challenge, of which the Empire State Building was one of the participants. And the solutions framework that has emerged from this, which we're calling resource efficient electrification. So this program, through New York's energy office, NYSERDA, brought together 10 leading real estate partners and their consultant groups from New York City. And together, these are some really large real estate companies. They represent just by themselves a huge portion of New York real estate. And they've all committed to decarbonize at least one of the tall buildings in their portfolios, with intent of replicating the solutions across their portfolios. And so over the course of a year and a half or so, NYSERDA and myself and other consultants worked with these real estate companies and their excellent consultant teams to map out decarbonization plans for the properties that they volunteered to participate. And one I think key piece of context here, and this program was very much focused on what to do about decarbonization of heating and water heating. So in New York City in particular today, the primary heating mode, as you might expect, is going to be gas boilers or gas furnaces, air handlers, as well as district steam that is gas fired. But if you look at today's performance of heat pumps, and COP here stands for coefficient of performance, that's a measure of how efficient an electric heating device is. Heat pumps can regularly achieve a COP of 1.5 or better. And at today's emissions rates, they're obviously pulling electricity from New York's grid. At today's emissions rates, you're often going to see, you're most often going to see that heat pumps do outperform gas alternatives today, as well as steam alternatives to heat. And as the electricity supply continues to decarbonize, per New York State's goals, electric heating is going to be the runaway favorite very quickly. And if you could think about it this way, in equipment that's installed today is going to be around for 20, 30, 50 years, depending on the system types, over the lifetime, the aggregated lifetime. Heat pump heating is going to be a carbon favorite. So with that context, we look at these tall buildings, which have unique challenges. I think that's why we're doing this webinar today. If we do unmitigated electrification, which is sort of a generic term, but think, electric resistance, inefficient heating, it could cause issues within the grid, spikes in the grid peaks. Estimations vary, but it could double grid peaks or more, shifting from a summer to a winter peak. But this resource efficient electrification approach combats that so that it can stay flat. Heat pump size and cost are also an issue, and so there's a certain capacity in these buildings today. Tall buildings especially are going to be limited on the physical size of the equipment, as well as sizing of the equipment. It may be an issue if it's sized for these sort of outlier heating peak conditions. But the resource efficient electrification approach that we're going to talk about is meant to abate that. And lastly, thinking about building emissions, the status quo is to use an audit-based incremental approach, which looks for short paybacks and sort of isolated projects. And that approach just isn't going to get us to full decarbonization. So this resource efficient electrification approach, what it comes down to is that there's a certain amount of fossil fueled heating equipment or capacity that's in place in these buildings today. And the gold bar here, there's a certain amount or certain size, right size heat pump, which is going to make sense for these buildings technically and economically. And to bridge the gap between those two, there are these enabling steps that we're seeing examples from in these projects through the Empire Building Challenge that reduce energy consumption and that reconfigure systems and take advantage of energy recovery and thermal storage to limit the size of the heat pumps that need to be installed in these buildings. And then we can talk about replacing those heat sources from either gas boilers, gas-fired district steam, and replacing those with various types of heat pumps. And so a little bit more detail on what we're talking about. So in these, the first step is really to review. So all of the buildings that participated, I'll give some examples, have dug deep into energy consumption and where possible disaggregate that to understand the simultaneous heating and cooling that's going on, and where in time and space these heat loads are. And then reducing loads, so especially if there are opportunities to make envelope improvements or controls improvements. And then it's about reconfiguring systems. And for some of these older buildings, especially legacy buildings, that is an important step because high temperature hot water or steam systems probably aren't going to be compatible with heat pump heat supply today. And so we're looking for opportunities to transition the building distribution systems over time, and work in heat recovery and storage opportunities, which is the next bucket there. And that's a whole, this heat recovery thing, I'll give some illustrative examples is a really big opportunity. And lastly, storing heat so that, again, we can limit the size of the heat pumps and make them technically and economically feasible. A more complicated version of this, maybe I won't spend time on this, but the idea is that these improvements can happen in isolated interventions in the building when they make sense. Tenant turnover, building asset repositioning on the market, sale or purchase, deferred maintenance, things like that. And there's going to be a timeline of when these things make sense within a building's lifetime. And every decision that's made in these buildings should be towards the ultimate goal of decarbonization. And that's a key thing that we've discovered working with these buildings. So quickly, just to highlight the importance of thermal recovery, heat recovery and storage. What we found working with some of these properties is that office buildings in particular, in cold climates like New York City, still have significant cooling loads for a big chunk of the cooling or of the heating season. The approach has been over recent decades to do so-called free cooling at those times, which takes advantage of cold outdoor air to cool those spaces without running a chiller or some other kind of compressor-based system. That economizer cycle or free cooling has been sort of touted recently, but in this new environment where we're trying to decarbonize heating, there's a new opportunity, which is rather than reject that unwanted heat from buildings, recover it, capture it, and store it until times of the day when it is used or when it is needed. Or if there are opportunities to use it concurrently in different parts of the building, say from shifting it from that heat from the core to the perimeter of the building, we find that offices can heat themselves for a big chunk of the year. And so this is where understanding the disaggregated load profiles of these buildings is really important. And we even came up with a clever name. Maybe you've heard of the duck curve when on a grid when solar generation outpaces demand in the middle of the day. Well, we're calling this the bat curve, which is to take advantage of that otherwise wasted or rejected heat and use it for the peripheral hours when that heat is wanted. So, and visually you can see this if you walk around a city like New York in the wintertime. There's heat being exhausted from these buildings, as well as the picture on the right here is heat off of the steam system. And so right now, the condensate from the steam system is that heat is actually just wasted today. And multifamily residential applications, it's a slightly different story, but still this idea of reduce, recover, and store is really important. Leveling out fluctuations in load, and so that we're not oversizing heat pumps to make it more technically and economically feasible. We see this with space heating, and then same thing with domestic hot water, which tends to have a very spiky load profile. So adding heat recovery and storage to level out those loads makes the heat pump transition more technically and economically feasible. And then when we've done all this stuff, now we can talk about converting the heat generation to heat pumps. And this is from a real example from an engineering firm that worked with us in this program, where designing a system today based on optimized carbon reduction and optimized economics, heat pumps were able to offset 80% of the heating loads today, very economically and technically feasible, with restraining the sizing of the heat pumps to meet the vast majority of the load, but in this case, not to meet the outlier peaks. And so the system used a hydronic system where it has optionality for the future to transition as technology solutions, as storage solutions, as carbon or policy impetus comes along to knock out the remaining part. But we can move on the bulk of heating immediately. And I guess one other point to clarify is that when we talk about heat pumps in a smaller residential application, the conversation is more about one-for-one swap outs. Like take out your boiler or your furnace and replace it with an air-to-air or air-to-water heat pumps. With these larger, more complex commercial buildings or larger thermal networks, we're actually talking about a range of heat pump solutions. There's a whole taxonomy, and some of those are central plant heat pump systems, air-to-air, air-to-water, ground source, or pick your source, storage source, water, wastewater source, heat recovery chillers. So there are central plants that could plug into ideally hydronic distribution systems in buildings. There are also types of heat pumps that sit in the building distribution systems. So they extract heat from a hydronic loop and put it into space, or water to water, or VRF, or variable refrigerant flow, or hybrid VRF is a similar version, which rather than running refrigerant around in space, runs water for the distribution. And then, of course, there are the sort of distributed standalone types of heat pumps, package terminal heat pumps through the wall, mini split systems, and then same equivalents on domestic hot water. And a given building may have multiple of these in central distributed arrangements. They may cascade temperatures for different purposes and conduct recovery. But this taxonomy of heat pumps is a language that we need to start talking about with these large complex buildings and thermal networks. And so all that stuff that I've talked about so far, each one of those points that I mentioned is really a category of technologies. And it's not a silver bullet that's going to come in and solve everything. What we have is this whole menu of opportunities. And if we plug these together and start connecting these buildings within thermal networks in the building that can do this heat recovery and thermal storage, and then heat generation from different sources and load balancing and shifting, we tie all this together, then it becomes achievable to decarbonizing these really challenging building types. And so with that, that's the framework, and that's emerged from working with these 10 real estate partners and other experts across the industry. I'll walk through the four examples. And so within this program, 10 real estate partners, and then they actually competed for large capital grants to start implementing the plans that they've developed. And so I'll walk through 4 case studies, 2 commercial buildings, and then 2 affordable housing multifamily buildings. So the first case study, the first winner of cohort 1 of the Empire Building Challenge was the Empire State Building, historic building, over 100 stories, 2.8 million square feet, post-war or pre-war construction. The legacy system was district steam and steam radiators at the perimeter, as well as coils in the air handlers of the building. So what the Empire State Building is doing is piloting water source heat pump energy recovery for a portion of the building on condenser loops. And so they're diving into this idea of thermal recovery and thermal shifting between spaces, because these commercial buildings, like I said, can't start to heat themselves for much of the building or for much of the heating season. Also heat recovery from steam condensate. They're piloting water and air source heat pumps on the domestic hot water side, for heating hot water and other steam reduction improvements. And so their approach, this is large, complex building, and since 1931, you can imagine all the variety of applications and systems that show up. And so what they're doing is doing a major pilot of this resource efficient electrification approach, focusing on those enabling steps of thermal recovery opportunities within the building. So that's the first one. And I'll share a link here that you can dig in. Actually, this building has come out with a detailed playbook that you could dig into. A second winner was 345 Hudson by the Hudson Square Partnership. And there's a team at Hines who is really leading the vision for this project. So this building has gas boilers and steam radiators. What they're doing is a full conversion, full electrification of the building over time. And so the transition of the building will occur as tenants turn over in these buildings. And they've come up with a few different tenant fit out options that are compatible with rooftop air source heat pumps. They'll also install a dedicated outdoor air system, and then heat recovery and thermal storage integrated into this hydronic loop. And so as tenants turn over, they'll convert their systems to one of three fit out packages that is compatible with this thermal network that is supplied by heat pump heating that includes heat recovery and thermal storage. And so this is a really exciting, comprehensive project. Again, they mapped that HVAC system transition to the asset life cycles to make it a rationalized investment. Case study 3, this building is an affordable housing multifamily building just outside city limits of New York City, 12 stories. This one had electric baseboard heating and then through the wall air conditioners. And what this one is doing is an exterior insulation overcladding of this 1973 building using an EFIS system, which will significantly reduce loads and increase comfort. And then they're installing a comprehensive heating, cooling, and domestic hot water system on hydronic loops. And so this one is using rooftop air source heat pumps to generate heat within those loops, and then those fan coils in the units that will be installed to do heating, and then water-to-water heat pumps for the domestic hot water. So again, really exciting, comprehensive project, starting with that load reduction through the envelope overcladding. Last example here is this is another multifamily project that is a majority affordable housing, 2 towers and then a lower building. This one again had electric resistance baseboard heating. This building is also doing that exterior overcladding to reduce heating loads by approximately a third. Installing new windows, and then the solution for this one was package terminal heat pumps through the walls. So rather than a centralized system, they're doing package terminal heat pumps. But again, they've reduced loads by a third through this overcladding approach. So it's really, again, a great comprehensive project. And they do have central air to water heat pumps for domestic hot water. So those are the 4 winners of cohort 1. There actually is a second cohort that's going to be announced here shortly. That all of the participants in cohort 1 and in cohort 2, one commonality is that they've all done this strategic decarbonization assessment process. And I think this is the magic for how we decarbonize these tall, challenging buildings. because this stuff isn't going to happen through incremental, short payback, sort of traditional audit-driven energy efficiency improvements like we've seen in controls or LED lighting. What this means is mapping out pathways, and maybe it's a decision tree with some options that get to full decarbonization, and then mapping the triggers for when those enabling steps can occur, so that it becomes more feasible to wean off of gas or fossil fueled district steam heating solutions. And the other thing, just to summarize what we've talked about from working with these partners, there are a number of sort of misconceptions or blind spots with these buildings. And again, one is this mindset of simple payback measures. And the solution there is to do this long-range strategic decarbonization assessment. There's a misconception that electrification occurs with one-for-one equipment swaps. Pull out your boiler, put in a heat pump. But that we know that may not be feasible. And so that's where these enabling steps that are part of resource efficient electrification comes in. Engineers, I think, are just beginning to sort of engage with this resource efficient electrification process, and they have an opportunity to lead on the vision and help be those expert consultants to their real estate clients. There's this mentality that this all has to happen at once, but like I showed in that example, it may happen in phases, knocking off 80% of the heating load immediately, and then solving, on a timeline that makes sense on real estate investment criteria. So there's also this idea that, I'll just wait till better technology comes along and it's easier. But okay, maybe there will be better technology. There's already good technology today, but one thing we should definitely start doing is these enabling steps, ideally shifting over towards more hydronic systems rather than steam, rather than forced air. And those hydronic systems will enable this heat recovery and thermal storage within these thermal network systems. People say tenants don't care about this stuff, but increasingly they do. Large corporates have environmental goals that they've declared. They're also comfort and air quality benefits. Electricity supply is going to be decarbonizing, as in New York and as in Europe, in coming decades, and electric heating is going to be a runaway favorite. And then mapping out this decision tree is how we overcome the potential disruption of these comprehensive projects. And so mapping to when tenants turn over. This has been a sort of rapid overview of what we've learned from working with Empire State Building and the other real estate partners of the Empire Building Challenge. We have lots more information on that. Part of the criteria, or part of the agreement with this program is that we want these solutions to scale, and so there's a number of resources. We've got our own webinar series that we're doing with Building Energy Exchange. That's going through a series of themes and doing deep dives into, say, the finance and some of the technical solutions. So I encourage everyone to check that out. We have this knowledge base, which reiterates a lot of what I've talked about with more detail, and you can grab all of these materials and use them for your own purposes. Please, let's create a common language on how we talk about this. And then just recently, we came out with these Empire Building playbooks. And so a number of the buildings that were participating have released detailed descriptions of their design and analysis process and the solutions, the technologies, system configurations that they're putting into those buildings. And those are available for download. And actually, we released those on Earth Day with great fanfare from some political celebrities. You may recognize one of the faces in there from the global stages. And so check out those playbooks. They go into more detail than what I went into today on these buildings. Empire State Building was one of the examples, one of the deep dives there. And then one more thing that I'm really excited about, and I would love to talk to more people about this, is that later this year, NYSERDA is going to be launching a almost $10 million technology prize focused on advancing technologies and solutions that fit into this resource efficient electrification approach that solve problems in tall and large and complex building types. And this prize is going to have a global purview. We want the latest, greatest emerging or established technologies from both sides of the Atlantic and actually all around the world. Let's translate it to New York. Let's share technology back and forth across. Let's accelerate it and grow it. And so we know that there are certain areas, especially district heating and thermal networking, where Europe is way out ahead, and we can learn lessons. We think there are technologies that could probably translate the other way across the Atlantic as well. And so if you have ideas of technologies, contact the program should launch fairly soon, but in the meantime, contact me and let's talk about technologies that plug into this framework. We have lots of those conversations. So stay tuned for that. Here's my contact information, as well as, again, some general links to the Empire Building Challenge with NYSERDA. But I love talking about this stuff, the technologies and emerging solutions and case studies. So please don't hesitate to reach out. And hello, David. I've not been managing or watching the chat or the Q&A. So
yeah, thank you. Thank you, Brett. Thank you, Brett. Yeah, well, we've been managing the questions, and we have a few questions for you from the audience, actually. Thanks a lot for this really interesting overview of what's happening there in your city and at this in this fantastic building. I mean, and we have some questions from the. I mean, the first one would be on. I mean, I understand that the steam heating that you have that is in place there in Manhattan since the 30s, is the last century, as you mentioned, is a sort, we can call it a sort of district heating. It's a centralized steam that reaches different buildings at the same time and heats the whole area. So one question from Elliot, he asks, would you advise heat pumps or connection to district heating for new buildings?
Yeah, I think so. I'll speak in sort of general terms here, and you know, there are discussions with Con Ed, this company that manages the district steam system, and so there are sort of separate parallel discussions about how they may, you know, start to decarbonize their systems. You know, what I think for new construction, the most important thing is to design in optionality. And what I mean by optionality is, like, don't put a steam distribution system within the building. I don't know if anybody's doing that anymore anyways, but put a hydronic system that can allow multiple things to plug into it. And within that hydronic system of the building, you can do that heat recovery exchange between spaces of the building. You could integrate thermal storage. I think that's the number one thing. What the heat sources are today, you know, there are enough solutions out there, large scale air source heat pumps, or in New York, we're seeing examples of urban geothermal. So, like, you know, drilling geothermal that's, you know, in some cases next to the building or underneath the building. Some are integrated with the foundation, with the piles of the building. So there are solutions there too, as well as wastewater heat recovery. There are solutions we're starting to see pop up in other parts of North America, to tap into even municipal wastewater. So there are these heat pump solutions out there today that are quite good. And so my inclination is to exhaust those opportunities first, because they're good, because they can take advantage of heat recovery and thermal storage, but first and foremost, design optionality into the buildings, because the technology is good today and it may continue to get better. Yeah, and then I also think the other thing, again, speaking in generalities, that we're excited about is this idea of community scale thermal networks. And by this we mean connecting buildings to take advantage of multiple buildings, heat generation systems, heat sharing across buildings, as well as potentially shared central resources. And so NYSERDA, in addition to this tall buildings program, they also have another program that's piloting community scale heat pumps. And so this is something we're excited about. Again, frankly, I think we could learn a lot of lessons from you all across the Atlantic. I think you're out ahead of us in a lot of ways. But that, looking for opportunities to do that kind of thing and tapping into district systems that are more hydronic systems and more compatible with heat pump generation is where the future lies.
Thank you. And also there's another question from Francesco Silvestri from Italy. Is asking, how important is it to have available space to decarbonize large buildings in cities as densely populated as New York, where the urban room's worth is so high? In Italy, we don't have such large buildings, but often in the main historic towns, the value is similar to New York in terms of worth, and space is not available. And also thank you for a very interesting presentation. So two things here: the space issue and which is linked to the fact that the space is very valuable and use.
Yep, absolutely. So a few points on that. Yes, space is going to be a critical issue, and I've am thinking of anecdotes I've seen from different buildings. There was an example of a commercial office building that tested basically a 1-for-1 swap out of equipment. And in order to do that, they had to absolutely maximize the available roof space and fill it up with these large air source heat pumps. And then even then it was going to be a challenge, and it was going to be very expensive. And by the way, they're taking out amenity roof spaces and things like that, which nobody wants to do. And so, but that's absent these enabling steps of heat recovery and thermal storage to limit those the sizes. You can put the thermal storage, and the space is hard to come by in these buildings oftentimes, but can you take advantage of abandoned spaces or chases or roof areas? So absent those enabling steps, yes, it may be a barrier, but we've seen enough examples now where we think it can be an example. A couple other considerations, like in multifamily buildings, there is this option of distributed systems through the wall systems. I focused more on tall buildings, which would tend to have more centralized systems or package terminal heat pumps, I suppose. But we are seeing a significant increase in success in mid-rise buildings or low-rise multifamily buildings that are doing split systems, putting condensers on the roofs and running roof return lines down to the living units, and that's becoming a commoditized sort of solution, and it doesn't take an excessive amount of roof space. It's not super invasive. There's one other consideration, I think, is that it's good to remember that, at least in New York, most of these buildings are going to have cooling systems today. And if they're centralized, that means relatively large cooling towers on the building, which may actually have greater height and visibility. And so I've seen examples of historic buildings where the heat pump solutions that are out there actually have a lower profile and lower visibility and can comply with historic preservation sort of criteria for visual appearance of buildings and mechanical spaces and roofs. So I think the every building is special. It's really hard to make generalizations. Yes, space can be an issue, but yes, resource efficient electrification can solve that through these enabling steps. And let's look at the big picture and see where there are opportunities, other value propositions for heat pumps in comparison to the alternatives.
Yeah, thank you. My one question is on I got lost a little bit on the timing. Maybe if you can come back to on this. So what has already been done there? What's in the pipeline? What's going to be left for the future? And when it comes to, particularly when it comes to like switching the main heat and heating and cooling source to heat pumps. What kind of refrigerants are you looking at? Because we know it's a big discussion also here in Europe now that we just have new regulation about that, and because there's a lot of talking about natural refrigerant being more efficient or able to have a higher temperature flow. So what's the discussion there if it's there?
Yeah, really good question. And there's I know a little bit about refrigerants. There are people that know a lot more about where the regulations are going. There's this there's a great series from a group called NYGEO. This sort of New York centered geothermal association, NYGEO, and they've got a couple great sessions on the nuances of refrigerants. I'll share a couple points on those. One, yes, we should expect some transition of refrigerant regulations. And in response to that, I would say, let's go back to this word optionality. Designing hydronic systems that either use hot water directly or use water to air or water to water heat pumps is always going to be the safest bet, because the refrigerants for the most part then happen in a central plant that may be on the roof or in other parts of the building rather than in the spaces. And so hydronic systems have that optionality, which is great. And people talk about VRF systems as one of the solutions. VRF is great because within office space, whether it's one floor of a building or some other low-rise commercial building, it can do heat exchange between spaces. That's great. There's another variation that's emerging called hybrid VRF, which rather than running refrigerant lines throughout the spaces uses water loop and does the heat exchange between those. And so I think we're going to see more of that because of concerns about where the refrigerant regulations may go related to not just global warming potential, but also fire restrictions, especially in this building typology and urban environments. One other thing I would say is I'm really excited about CO2 heat pumps. So in this case, CO2 is a good thing because it has a lower global warming potential than other refrigerants. It also tends to do better at lower ambient temperatures for air source heat pumps and can achieve greater temperature lifts. And I think we're just starting to see products emerge. There are the first products that are coming out are sort of domestic hot water focused, where you need that high temperature lift. And I think we're going to continue to see evolution of those technologies. I saw that the GSA, which is the U.S. federal government's landlord, the largest single landlord in the U.S., just named, I think it was 9 new technologies that they're going to be testing and installing across their portfolio, and one of those was the CO2 refrigerant heat pump solution. So I think we're going to start to see a lot of activity in that space and increased focus on those. But yeah, so hydronic systems are great. They have the optionality, and then we'll see where the emerging technology goes.
Thank you. We have another question, which is what kind of in all Europe you have a lot of historic buildings, and there's another question from Italy, where you have a lot of this problem of urban regulation that are kind of urban building codes that prevent cladding, so the envelope the envelope of cladding overcladding, which would be the most obvious thing to do when it comes to trimming the energy consumption of the building. So what types of overcladding are used, for example, on historical stone or brick buildings in US, if you have any knowledge of that, and have you been using overcladding in this specific project or one of the projects you were mentioning? I remember one from 1973 is cladded, but that wouldn't qualify as probably as a heritage building. But in the other buildings, have you been using it?
Yep. So the two examples that I shared used EFIS overcladding, and you're right, those particular buildings wouldn't exactly qualify as historic building. At least they're not under the purview of historic preservation, because they totally change the exterior appearance of the building, and in those cases it was seen as a plus. It's actually a part of the driver for it. Historic buildings, what we have seen is, and this happens in, I'm thinking about some multifamily, there's a dorm example, and also adaptive reuse of buildings, converting to multifamily, where rather than going outboard overcladding, going inboard, which is a little bit scary. So my background, I started my career as an architect, and insulating inwards rightfully could make people a little bit nervous because of condensation concerns. But buildings are starting to do this. And so it's building out or replacing the interior finishes. And then I've seen spray foam insulation, which has the closed cell spray foam is able to control the moisture well enough. And then putting a new finish over top of that. And so, and there are examples out there of historic buildings that are doing that and achieving passive house levels of airtightness and passive house levels of thermal resistance insulation in the buildings. With regards to windows, I think there are a couple things. Again, I've seen examples of taking out historic windows, and a lot of times the profile of the sashes is very important to the visual, the maintaining the historic visual character. There are ways of achieving that sort of artificially, the depth and profile of these buildings with sort of advanced framing design, working closely with window manufacturers. There are also window insert technologies out there that I've seen there, and there are a couple companies that have products that go inboard. This is just a custom sized window with a gasket on it that slides in. It's not permanent, and it doesn't change the visual character. And so the historic preservationists should be content with those. So I think that's another solution on the window side that is perhaps less invasive than total window replacement. So there are solutions out there. There are examples, fairly custom at this point, but it can be done.
Thank you. I also have a couple of final questions for you. And first would be, a lot of the project, a lot of the let's say the results of the project are based on this concept of offsetting the peaks and reusing, actually sharing changing the loads from across time and space, and therefore you're reusing heat and cold in the building. But do these operations only happen within the building, or is it like do these entail some sort of exchange with the surrounding buildings, or is it like more of a block operation, or is it just a single building operation?
Yeah, it can be either. And with these larger buildings, they're big enough and complex enough that you could call it a thermal network even in the building, shifting building from the east to the west side of the building or from the core to the perimeter. But it absolutely can also work within a larger context, and that's where I think it'll get really exciting. One of the buildings, the Hudson Square project, the second one that I showed, actually is making a connection to a neighboring new construction building that has geothermal piles, and so and it's the same ownership, and so they're able to do that and look for heat sharing opportunities. So it does exist. It can be done. Again, here I think Europe is way out ahead in this realm. Well, what we do see in the US, I think, is like on campus applications. So university campuses, there are a lot more of this type of thing, and we're starting to see conversions from steam to hot water to enable this kind of thing to happen at the campus scale. And it would be great to see more instances of this in municipal systems or or private investments. There's one example that I heard of in Seattle, so West Coast, Northwest the US, where a building received approvals to tap into and draw heat from wastewater, municipal wastewater. It's sort of the first of its kind in the US, as far as I know. And now that building is looking for opportunities to sell the heat to neighboring buildings. And so now they have this asset and it's growing. It's an organic sort of emerging opportunity led in that case by the private sector once they got over the sort of municipal hurdles. So I think that that's a huge opportunity area. Would like to see more innovation and overcoming some of the regulatory restrictions to doing that kind of thing in mass.
And one last question would be, okay, so what is the timing, or what are the actions you're taking for going from pilots to mainstream, like say policies in the different in the market and the building market in New York? I mean, how do you see this coming in? What's the plan there to transform this into like the new normal?
Yep, totally. Because this program's Empire Building Challenge, right, awarded these large grants, $5 million a piece to those 4 projects. Cohort 2 will also have a competition for large multi-million-dollar grants. But obviously we can't do that for 50,000 properties across New York. We have to scale. And so I think there are 2 things, or at least 2 things. One is the key part of this program is to generate the ideas and be an open book to share how those solutions work. And so it's a knowledge creation. It's creating a shared knowledge base that especially consultants out there that in the industry can tap into. So that's first thing. Doing things like this, creating web resources that are clear and easily accessible for consultants. The second part is perhaps harder, but I would say even more exciting, which is really there's that Empire Technology Prize that's coming up. So we need to find ways to discover the technologies, accelerate them in the marketplace, and I think a crucial part is all these fragmented technologies, widgets, if you will, need to be put into a thought framework, a heuristic, where they're working together in concert to create these thermal networks that solve problems for these challenging building types. And so that's something I think we're just starting to think about, like how to accelerate those technologies and how to assemble the ecosystems of solutions, integrative solutions that are going to be necessary for these buildings, and then try to commoditize it as much as possible. Buildings are all special snowflakes, but we have to figure out ways of mass customizing these approaches.
Well, yes, thanks. Indeed, we have to. Well, Brett, that was really, really insightful. Thanks so much for being with us today. I think we've come to we're coming close to the end of our meeting today. Let me just finish this with reminding that on the 14th of June, we will have Danielle Manley from the Urban Green Council that will speak about speak about policies related to this, to the topics of today. So, and Brett will also be there. So we'll meet you again in a month or so. And the title will be "Big Cities Going Out of Fossil Fuels: The Case of New York City." Again, we're looking at New York City as an iconic big city, big apple. So that it can be of inspiration also for other not so big but still big cities in Europe. We'll also have another webinar, and it's going to be more focused on technologies such as district heating heat pumps, from like water to heating, and also other like centralized blocks of flats, high temperature heat pumps, and as you mentioned, there are new opportunities coming up there in terms of technology like low temperature district heating that are connected to different split heat pumps scattered around the territory instead of having one central unit. I mean, you're looking at different technologies, and we're going to have some sort of showcasing these technologies in another webinar, and we'll keep everyone in the room posted. So we'll send you out the invitation. We would be very happy if you could also, this webinar has been recorded. It will be on YouTube. We'll be very happy if you can share the words in your social networks and let everybody know, especially technicians, people, engineers and architects that might be interested. Maybe if you could not be with us today, they might be interested. So it's going to be it's going to live out there. And so thanks in advance for helping us to reach out more people. And with this, I would also thank Nicoletta and Antonio, my colleagues, for the technical part of the organization. And nothing more than that. And thanks, Brett, again, and see you next time.
Thank you so much.
Bye, everyone.